Good day students, welcome back to PF101, Object Oriented Programming. So, we're now on week 5 lesson 4, coding with variables, named constants, and calculations. In this lesson, we will learn to do calculations using Visual Basic. We will start with text values input by the user. Next is we need to convert the input values into numeric, perform calculation and display the result to the end user. But, we must have to learn about the variables and constants. What is the different types of data used by Visual Basic? Variables are declared differently, it depends on where you want to use it and how long you will need to retain the values. So, to further understand what are the things to be learned today, here are the learning outcomes. Good day students, welcome back to PF101, Object Oriented Programming. So, we're now on week 5 lesson 4, coding with variables, named constants, and calculations. In this lesson, we will learn to do calculations using Visual Basic. We will start with text values input by the user. Next is we need to convert the input values into numeric, perform calculation and display the result to the end user. But, we must have to learn about the variables and constants. What is the different types of data used by Visual Basic? Variables are declared differently, it depends on where you want to use it and how long you will need to retain the values. So, to further understand what are the things to be learned today, here are the learning outcomes. At the end of this lesson, the students should be able to: first, differentiate types of variables. Second, explain the different uses of variables. Third, define constant, modifiers, statement and directives. Lastly, enumerate Visual Basic operators and data types. So now, let's proceed with handling data. Variables. Provide a means to store data values that are not stored in files. Support the computation of values through their use in formulas in assignment statements. Represent locations in a computer's memory. Are assigned a unique name for reference when writing computer code. The figure in the next slide illustrates the concept of a variable name associated with locations in random access memory, wherein values are stored to memory locations, represented by the rectangle. The stored values can vary over time. Each memory location is assigned a unique variable name that is used to reference the location when you write a program. Constants are similar to variables in that constants are also values that are stored to memory locations. Variables can change values during program execution, but constants cannot change value during program execution. Variables are created or declared with the dim statement. Dim is short for dimension, which means size. Here are some example dim statements. Later we will cover the rules for using the dim statement. For now, you just need to understand that in order to reserve a location in memory for storing a value, you need to use the dim statement. These statements create an integer variable, stores whole numbers, and 2 decimal variables, stores decimal values that have a decimal point. Dim int number of students as integer. Dim dectuatution as decimal. Dim dic gross paydu as decimal. Constants are declared with the const statement. Here is an example const statement. Note that the statement assigns a value of 0.2 to the constant name ting discount_rate. Of course, 0.2 is the single precision equivalent of 20%. The F after 0.2 stands for single precision. Const ting discount_rate as single equals 0.2 F. There are different examples of data that may be stored to computer memory. Customer name, string, stores alphabetic characters. Social security number, string, numbers that are not used in computations. Customer number, string, numbers that are not used in computations. Balance due, decimal, used in calculations and often requires a decimal point to separate dollars and cents. Quantity in inventory, integer or short, selection depends on how large the quantity in inventory will be, but the quantity is usually a whole number. Sales tax rate, single or decimal, used to store a percentage value, also used for scientific calculations. Most business applications primarily use string, decimal, single, and integer data types. There are different examples of data that may be stored to computer memory. Customer name, string, stores alphabetic characters. Social security number, string, numbers that are not used in computations. Customer number, string, numbers that are not used in computations. Balance due, decimal, used in calculations and often requires a decimal point to separate dollars and cents. Quantity in inventory, integer or short, selection depends on how large the quantity in inventory will be, but the quantity is usually a whole number. Sales tax rate, single or decimal, used to store a percentage value, also used for scientific calculations. Balance due, decimal, used in calculations and often requires a decimal point to separate dollars and cents. Quantity in inventory, integer or short, selection depends on how large the quantity in inventory will be, but the quantity is usually a whole number. Sales tax rate, single or decimal, used to store a percentage value, also used for scientific calculations. Naming rules for variables and constants. When it comes to naming variables and constants, you as the programmer will decide what to name variables and constants that will be used in developing a project, and with that there are technical rules you must follow when creating variable and constant names. The following are the rules that you should follow. Names can include letters, digits, and the underscore, but must begin with a letter. Names cannot contain spaces or periods. Names cannot be visual basic reserved words, keywords, such as let, print, dim, or const. Names are not case sensitive. This means that total integer, and total integer are all equivalent names. For all intensive purposes, a name can be as long as you want. The actual limit is 16,383 characters in length. Note, in earlier versions of Visual Basic, the maximum length of an identifier was 255 characters. In VisualBasic.net, you can forget about the length limit, since the maximum is now 16,383. Declaring variables. Declare variables that are local with the dim statement. Declare variables that are module level with the private statement. Dim statement, use this to declare variables and constants inside a procedure. These are local variables. The dim statement needs to specify a variable/constant name and data type. Specifying an initial value for a variable is optional. Constants must have an initial value specified. Syntax for variable declaration. Attribute list access modifier shared shadows static. Read only dim with events variable list. Where attribute list is a list of attributes that apply to the variable. Optional. Access modifier defines the access levels of the variables. It has values as public, protected friend, and private. Optional. Shared declares a shared variable, which is not associated with any specific instance of a class or structure, rather available to all the instances of the class or structure. Optional. Shadows indicate that the variable redeclares and hides an identically named element, or set of overloaded elements, in a base class. Optional. Static indicates that the variable will retain its value, even when the after termination of the procedure in which it is declared. Optional. Read only means the variable can be read, but not written. Optional. With events specifies that the variable is used to respond to events raised by the instance assigned to the variable. Optional. Variable list provides the list of variables declared. Each variable in the variable list has the following syntax. Variable name, bounds list, as new data type equals initializer. Where variable name is the name of the variable. Bounds list optional. It provides list of bounds of each dimension of an array variable. New optional. It creates a new instance of the class when the dim statement runs. Data type required if option strict is on. It specifies the data type of the variable. Initializer optional if new is not specified. Expression that is evaluated and assigned to the variable when it is created. Let's have an example in declaring a variable. Dim student name string as string. Dim count students integer as integer. Dim account balance decimal as decimal equals 100d. You can also declare more than one variable in a dim statement. Dim student name string, major string as string. Dim subtotal decimal, total decimal, tax amount due decimal as decimal. Declaring constants. When you declare a constant, you set a meaningful name to a value. However, if constant already declared, you cannot modify it or assign a new value. Constant must be declared within a procedure or in the declaration section of a module, class, or structure. Wherein, class constants are private by default, thus it can also declared as public, protected, friend or protected friend. Declare constants with the const statement. Constants are similar to variables. Constants are values that are stored to memory locations. However, a constant cannot have its value changed during program execution. Constant values are generally fixed over time. Example: sales tax rate or name of one of the states in the United States. Let's look with an example below. Const sales underscore tax underscore rate underscore single as single equals 0.0725 f. Const big underscore state underscore name underscore string asstring equals Alaska. Const title underscore string as string equals data entry error. Const max underscore size underscore integer as integer equals 4000. String, text or character, constants are assigned values within the double quote marks. This statement stores double quote marks as part of the string. Do this by typing two double quote marks together. Const course underscore title underscore string as string equals programming Visual Basic. Numeric constants like those shown above do not use double quote marks, just type the numeric value numbers. Follow these rules for assigning numeric values to constants. You can use numbers, a decimal point, and a plus, or minus, sign. Do not include special characters such as a comma, $sign, or other special characters. Append one of these characters to the end of the numeric constant or variable to denote a data type declaration. If you don't want to use these, a whole number is assumed to be integer and a fractional value is assumed to be double. Scope of variables and constants. A variable and constants might be visible, scope, or present in the project in only one form or one procedure. Each variable, or constant, has a finite lifetime and visibility, termed the scope. The variable lifetime is how long the variable exists before the computer operating system garbage collects the memory allocated to the stored value. There are 4 levels of scope. Namespace, use a public shared declaration instead of dim. The variable is visible within the entire project, applicable to a project with multiple forms. The variable is project-wide and can be used in any procedure in any form in the project. The variable memory allocation is garbage collected when application execution terminates. Module level, usually use private to declare the variable, use const to declare the constant. A variable / constant can be used in any procedure on a specific form. It is not visible to other forms. Use module level variables when the values that are stored in their memory locations are used in more than one procedure, click event or other type of procedure. module-level variable or constant is created, allocated memory, when a form loads into memory and the variable or constant remains in memory until the form is unloaded. Local, use dim to declare the variable, use const to declare the constant. A variable / constant is declared and used only within a single procedure. Variable lifetime is the period for which a variable exists. When a procedure executes, such as when you click on a button control, each variable and constant declared as local within the procedure executes, uncreated when the procedure executes the end substatement. Each time you click the button, a new set of variables and constants are created. Block, use dim to declare the variable, use const to declare the constant. The variable / constant is only visible within a small portion of a procedure. These variables / constants are rarely created. This figure illustrates where to declare local versus module-level variables / constants. Later you will learn to declare namespace and block variables and constants and when to use the public keyword in place of private. Converting output data types. Converting the output of a data types is a process of changing the value of one data type to another is called a conversion. Wherein, it can be converted widely or narrowly, but it depends on the capacity of data types or the syntax in the source code. In order to display numeric variable values as output, the values must be converted from numeric data types to string in order to store the data to the text property of a text box control. Use the tossed ring method. These examples show converting strings to a numeric representation with 2 digits to the right of the decimal, N2, and currency with 2 digits to the right of the decimal, C2, as well as no digits to the right of a number, N0, that is N0, not NO. Here's an example of displaying a numeric variable. Subtotal textbox.text equals subtotal decimal dot tossed ring, N2. Sales tax textbox.text equals sales tax decimal dot tossed ring, C2. Quantity textbox.text equals quantity integer dot tossed ring, N0. Converting a data type can be classified as implicit conversion or explicit conversion. Where implicit conversion, this is conversion by VB from a narrower to wider data type, less memory to more memory. This is done automatically as there is no danger of losing any precision. In this example, an integer, 4 bytes, is converted to a double, 8 bytes. Example. Bigger number double equals smaller number integer. Explicit conversion, this is also called casting and is used to convert between numeric data types that do not support implicit conversion. This table shows use of the convert method to convert one numeric data type to another numeric data type. Note that fractional values are rounded when converting to integer. Use the parse method to convert a string to a number performing calculations. VB uses a wider data type when calculations include unlike data types or to parse the value in a text box control. This example produces a decimal result. Average sale decimal equals total sales decimal / count integer. Summary rules. Use the convert method to convert a type of number to a different type of number. Arithmetic operators. Arithmetic operators are used to perform calculations of numeric values, variables, constants, functions, etc. Also, arithmetic operators are considered as bit shift operators, whereas it act at the level of individual bits of the operands and shift the pattern of the bit either to left or right. The arithmetic operators are the same as in many other programming languages. These are plus addition, subtraction, multiplication, / division, exponentiation, / integer division, modulus division. Exponentiation, this raises a number to the specified power, the result produced is data type double. Example. Value squared double equals number decimal 2. Value cubed double equals number decimal 3. Integer division, divide one integer by another leaving an integer result and discarding the remainder, if any. Example. If the variable minutes integer equals 130, then this expression returns the value of 2 hours. Hours integer equals minutes integer \60. Modulus division, this returns the remainder of a division operation. Using the same value for minutes integer equals 500, this expression returns the value 20 minutes and can be used to calculate the amount of overtime worked for an 8-hour workday. Minutes integer equals minutes integer mod 60. Order of precedence. The order of precedence for expressions that have more than one operation is the same as for other programming languages. Evaluate values and calculation symbols in this order. 1. Values enclosed inside parentheses. 2. Exponentiation. 3. Multiplication and division. 4. Integer division. 5. Modulus division. 6. Addition and subtraction. Assignment operators and formulas. The equal sign is the assignment operator. It means store the value of the expression on the right side of the equal sign to the memory variable named on the left side of the equal sign. Here are the examples. Item value decimal equals quantity integer asterisk price decimal. Hours worked single equals minutes worked single /60f. Net profit decimal equals gross sales decimal, cost goods sold decimal. The plus symbol combined with the equal sign allows you to accumulate a value in a memory variable. Examples. Total sales decimal plus equals sale amount decimal is equivalent to the following. It means take the current value of total sales decimal and add to it the value of sale amount decimal and store it back to total sales decimal. It gets bigger and bigger. Total sales decimal equals total sales decimal plus sale amount decimal. The minus symbol combined with the equal sign allows you to decrement or count backwards. Examples. Count integer equals 1 is equivalent to count integer equals count integer 1. The minus symbol combined with the equal sign allows you to decrement or count backwards. Examples. Count integer equals 1 is equivalent to count integer equals count integer 1. That's all for today's lesson. Thank you for listening. I hope you've learned something new today.